So guys, we are in another section, and this section we're looking at equilibrium of three forces acting at a point. So this section is actually specific because we're looking at what? Just three forces acting at a point. So if you guys can remember, or if you have been watching the video from the beginning, there was a diagram that I've been drawing consistently, and it's like this. So let's just call this side. Let's call it P. Let's call it Q. Of course, this is the resultant, and this is the what? The equilibrant. So the equilibrant is equal in magnitude with the resultant, but of course, they are in opposite direction. So this point now, this point is in equilibrium. So what? Then what? The equilibrium. And we have three major forces acting on this point. The first force is what? The force P. The second is what? Is the force Q. While the third one is what? Is the force E. This equilibrant is balancing this P and Q, making this body, let's assume the body is here, making this body or this point to be in what? In equilibrium. Do you understand? Now you might ask, okay, why didn't I count this R? This R is what? A resultant. It is the sum total of the P and the Q. So I can't say P, Q, and R together. Of course, I'll be wrong because this R is that single force that has this, that has the same effect in magnitude as two forces or more, of course, acting together. So the forces that are keeping this body in equilibrium is this force P, this force Q, and this equilibrant force, which is what? Balancing them. So it is that we can represent these three forces that are keeping this body in equilibrium. We can represent them with the three sides of a triangle. Do you understand? With the three sides of a triangle. So how do we do that? Please note these arrows that I'm writing here, that I'm pointing out here. They are also likewise important. So it's not just for joking matter. So in a triangle, this is a typical triangle. Okay, my drawing is really bad, but we'll manage. With a triangle, a right angle what? Triangle. So we can represent these three sides in what? In a right angle triangle. Remember, we're looking at what? As P, Q, and what? And E. We're looking at R, please. R is the resultant. So this P, Q, and E, that the one keeping this body in what? In equilibrium. Remember, E, which is the equilibrant, is balancing this P and Q. You get, which is like, yeah, it's balancing what? It's balancing P and Q. So, of course, we can represent here as P. We can represent here as what? As Q. And here is what? Is E. Do you understand? So this is representing the three forces keeping a body in equilibrium. What represents is what? With the sides of a triangle. So when we start taking questions, you start seeing how they are what? How they are applicable. And this E is what? The equilibrant. And it's what? The longest side, of course. The longest side, which is what? The hypotenuse. So this P and this Q, they are what? This is the opposite, this is what? The adjacent. Remember, it depends on the question we are given or the diagram we are given. That is how we represent it in what? In a triangle. But note that the three forces that are keeping that body or that point in equilibrium can be represented by the three sides of a what? Of a triangle. So let's take a question. Let's take a question. So let me state the principle of the triangle of forces. So we call this the principle of what? The triangle of forces. Let me write it here. The what? The triangle of forces. The triangle of what? Of forces. So the principle says that if three forces are in equilibrium, these three forces, one, let me use my blue marker to mark it out for you so you can see it clearly. One, if three forces, 1, 2, and 3 are in what? Are in equilibrium, they can be represented both in magnitude and in direction by the three sides of a triangle taking in what? In order. So if these forces 1, 2, 3, they're in equilibrium, 1, 2, 3, 1, 2, 3, they're in equilibrium, they can be what? Represented in what? In both magnitude and direction by the what? The three sides of a what? Of a what? Of a triangle taken in what? In order. So let's take an example to help us what? Illustrate this. Let's take an example to help us illustrate this. So let me clean here. Let me clear here. We are going for a very, very, very long ride. Not that long, but just a ride though. A ride. So let's write the example out. A mass, I'm going to use a black marker. A mass 2 kg is supported by 2 cords which make angles of 30 degrees and 50 degrees with the vertical. Calculate the tension in the 2 cords. So this question says that a mass 2 kg is supported by 2 cords, which makes angles of 30 degrees and 50 degrees with what? With the vertical. Did I write that well? With the vertical. Calculate the tension in the 2 cords. So it means that one thing you must know in physics is that you must master the art of bringing problems to life, of bringing them. I don't know which English I will use, but of you interpreting questions. Now, a mass 2 kg is supported by what? By 2 cords. That means if we have a mass 2 kg, let's do it like this. This is a mass 2 kg. It is what? Supported by what? By 2 cords. This is the first cord. This, of course, is what? The second cord. And this is also, and this is the first cord, second cord, supported by 2 cords, which make angles of 30 and 50 degrees with the vertical. Let's take this as a vertical. Of course, they have their own vertical since there are 2 cords. Now, the angle here is 50 degrees. No, 50 or 30, anyone. Let's say 30 first. And what? 50 what? Degree. The angle here with the vertical. So they are like, calculate the tension in the 2 cords. Now, this 2 kg mass is hanging here. 2 ropes are pulling it. 2 ropes are holding it. That means there's a tension in this cord and the tension in this cord. And the tension, of course, tension is a force, you know, right? Tension is a force, like a pulling force. Now, this cord is holding this mass. This cord is like what? Holding this mass. So the force, the tension in the cords is acting upward, in an upward direction that the rope or the cord is pulling it. Do you get that kind of stuff? Yeah. So this cord is holding this mass in this direction. It's holding it like this. So the force is acting up. Same thing goes as this. But where is the force? Because this mass too has its own force. Of course, the force of this mass will be what? Will be acting downwards. It will be what? It will be acting downwards because since these two are pulling it up, this mass, because of the force of gravity, will be what? Will be going downwards. Do you understand? Now we can see that we now have something like this. Let me just draw it here. We have something like this. Showing you that this one that is going down like this is what? An equilibrant of these two. Do you understand? It's an equilibrant of these two. But let's continue. Let's continue. So if you want to represent these 3 forces, now we have 3 forces here. The first force is this one. This will be now if you want to, now this mass is 2 kg, right? If you want to convert 2 kg to newton, I mean to a force, this is a mass. So it's what 2 times 10 because that will be what mass times what acceleration. That will be 2 times 10. That will be what 20 newton. That means the force that this mass is exerting is what is 20 what 20 newton. Do you understand? So we have three forces now. So we want to use the side of a triangle because that's what we're looking at. We want to use the side of a triangle to what? To represent them. So let's do that. So this is the equilibrium, of course. You can see that it's balancing what? The other two forces. So if we want to represent this, what we'll do is that we'll take it like this. This is going like this. Why this one is going like this? So we can come this way and say that one of them is going like this, while another one of them is going what? Is going like this. Now remember, this and this are what? Are this and this. Please note that this and this are what? This and this. And they both make an angle what? 30 degree. And what? 50 degree with what? The vertical. This is a what? A vertical line. This is a what? A vertical line. So they make what? An angle 30 degree and what? 50 degree with what? With the vertical. Do you understand? With the vertical. So we are asked to look for the tension in the two chords. That means we have to look for what? This T1 here and this what? T2 here. But we know the value of the force here. The value of the force here is what? 20 newton. Please note, tension is a what? Is a force, a form of force. Tension is a form of force. So now, how can we go about this? We can go about looking for the tension in these two chords by using what? By using sine rule. By using what? By using sine rule. It's pretty what? It's pretty simple. So let's clean this place and let's continue with our this thing. So we can use what? We can use sine rule. So from here, of course, the total sum of angles in a triangle is what? Is 180. So if we have 50 degrees here and we have 50 degrees, I mean 30 degrees here, that means the angle here will be what? Will be, that will be, this is 50 for 30. The angle here will be what? Will be 100 degrees because we have what? 50, that'll be 180 minus 50 plus 30. That'll give you what? 180 minus 80 degree. That'll give you what? 100 degree. That's how we got the angle left here. Before we were not given this angle. So the angle here is what? Is 100 degree. So if we want to use sine rule, we use what? So that'll be what? Remember, sine rule is the side divided by what? The sine of the angle opposite to that what? To that side. That is A over sine A equal to B over sine B equal to what? C over what? Sine C. So we can say T1 over what? The angle opposite T1 is what? 50. T1 over what? Sine 50. This is looking like more of 80. Sine 50. Go to what? T2 to what? Sine 30. T2 what? Sine 30. Go to what? Let's call this T3. I don't call it T3, but let's call it T3. It's not bad. T3. T3 over what? Sine 100. So now, if we want to look for T1 and T2, what we have to do is that we just pick. So we'll either equate T2. Remember, T1 over sine 50 is equal to what? T2 over what? Sine 30 equal to what? T3 over what? Sine 100. So we can either pick these two and solve for T2. Then, okay, we know T3. T3 is 20 newton. Of course, this is it. 20 newton. So we can pick T2 and solve with this one. Then we can pick T1 and solve with this one. So let's solve for T2 first. So T2 over sine 30 equal to what? 20 over what? Sine 100. You cross multiply, that be 20 times sine 30 divided by what? Sine 100, give you what? T2. So T2, so let me do this. My calculator. So that will be 20 times sine 30. Sine 30 is 0.5 divided by sine 100. So you get T2 to give you what? 10.15 Newton. So T2 is what? Is 10.15 Newton. So let's get for T1. So that will be T1 over sine 50 equal to what? 20 over sine 100. Still the same thing. So 20 times sine 50 all over sine 100 is equal to what? T1. So T1 got to what? 15.6 Newton approximately. So we've gotten our T1 and our T2. So our T1 is what? 15.6 Newton. Our T2 is what? 10.15 Newton. So how do we get this? We got this using what? The triangle, by representing the three forces with the sides of a what? Of a triangle. And that law is called the principle of what? Triangle of what? Of forces. The principle of what? Triangle of forces. So this is not the only example we are doing. So you might be confused, but with the next example that I will do, you'll get more clarity. So guys, we are looking at another question here, and we are still on the principle of what? Triangle of forces. So the two examples that I'm doing here, they actually have diagrams already. So they are not they're not entirely word problems. They have diagrams here. So this question says that the diagram below illustrates three forces: T1, T2, and 100 Newton. This T1, T2, and what? 100 Newton. So, and then what? They're in equilibrium. They're in equilibrium. Determine the magnitude of which T. It should be T1. Of T1. Of T1. Let us look for T1. So they calculate the magnitude of what? Of T1. You understand? So we're given T1 and T2. We're given 100 Newton. We have three forces. So T1, T2, and 100 Newton. T1, T2, and 100 Newton. So we're asked to look for what? The magnitude of T1. So before solving this question, we have to represent it in what? In a triangle. So how do we do that? It's very simple. Let's look at it. Now, this T2, this T1 is this thing. They're just like walls or hold fast. As simple as that. So to represent these three forces in a triangle, if you look at this diagram, you know that okay, this 100 Newton is actually the what? The equilibrant. So let me tell something that force that is going in, and I don't know how to put it, in a whole different direction is the equilibrant. It's easy to know the equilibrant. 100 Newton is obviously what? The equilibrant, but let us do what we want to do. So let's draw the triangle. So let's represent T1. T1 is going this way. So this is what? This T1 is going horizontally in this way. You get why this 100 Newton is what? Is going down. You understand? While this T2 is this way, like this. So we can put it like this. Do you understand? Let me make this arrow clear here. Let me make this arrow clear too. Oh, my drawing. So this is going like this. This is going like this. Can you see? So this is T1. This is 100 Newton. And this is what? This T2. So remember, this T2 makes this angle with the vertical. So this angle 30 here is, this will be 30 here, because it is making this angle with the vertical. If I put the 30 here, that means I'm saying T2 is making this angle with the what? With the horizontal, but that's wrong. T2 here is making the angle with the what? With the vertical. So, of course, this right angle triangle, this here will be 90, of course. If I was to just start, if we want to represent angle, here will be 90. So to look for the magnitude of T1 is quite easy. We can do this in different ways. We can use sine rule, but sine rule, I don't know, should we use sine rule? If you want to use sine rule, that means here will be 60. No. The total angles in the triangle is what? 180. We have 90 here, we have 30 here, that is 120. So it remains 60. 180 minus 120 will give you what? 60 degrees here. So if you use sine rule, just do 100 over sine 60 to give us T2. Okay, we'll look for T1. Let's use T1. T1 over what? Sine 30. So if you cross multiply, you now have like 100 times sine 30 divided by what? Sine 60 will give you what? T1. So T1, so that will be 100 times sine 30 divided by what? Sine 60 will give you what? So T1 will be 57.74. So T1, let me write it here. T1 was 57.74 Newton. So it's that simple. If we are looking for T1, you will go the same way if you are looking for T2. Just do your T2 divided by what? Sine 90 and you get it. But do we really have to go this way all the time? I think there's a faster way. So the faster way to do this is by using SOHCAHTOA, and that's what we'll be using from now on. So let me just explain, let me give a brief explanation on what SOHCAHTOA is. So we have what? SOHCAHTOA. So this SOHCAHTOA means what? Sine theta equal to what? Opposite over what? Hypotenuse. Then put HYP. So if you have a triangle, a rectangle triangle, like this, of course, the side facing the angle is what? It's the opposite. This is the adjacent. This is the what? Hypotenuse. So if you are looking for the hypotenuse and you have the opposite, you can use sine theta to get opposite of of hypotenuse, and you get your hypotenuse. That's if you have the value of the opposite. Same thing goes to cos. So this C means what? Cos theta equal to what? Adjacent over what? Hypotenuse. Why this one means what? Tan theta equal to what? Opposite over what? Adjacent. So it's that simple. That's also SOHCAHTOA for you. So let's assume we want to use this SOHCAHTOA to solve for T2. So I might clean some things that we did not have there before, my duster. So we did not have this here before. We don't have to look for ourselves, and we did not have this here before too. Let's assume we don't have all this. So how do we look for T2? So of course, based on this diagram, T1 is the what? Is the opposite. T1 is the what? Is the opposite. And yeah, is T1 the opposite? No, it's the side facing this angle that is the opposite. The side facing this angle, the angle here. Of course, we don't have any value for it. So 100 is the opposite. 100 is the opposite. So to get the T2, what will we use? Now we have the opposite, right? And do we have the adjacent? We don't have the adjacent. So we cannot use tan theta. But can we use cos theta? We have the adjacent and the hypotenuse. No, we can only use sine theta. We have the opposite and we are looking for the hypotenuse, which is T2. This is the hypotenuse, this is T2. So if we are to use sine theta, that will be sine theta equal to what? Opposite, which is what? 100 by what? Hypotenuse over hypotenuse. But the angle that we will use, if you want to go this way, will be this angle, will be this sine, will be this angle. So here is 90, of course, right angle triangle, and here is what? Here will be 60, of course. So that will be what? Sine 60 equal to what? 100 by what? Hypotenuse. So to get that part, that will be 100 divided by sine 60. And we are marvelously wrong. So that is 100 divided by what? Sine 60. So remember, this HYP is a T2. The hypotenuse is what? Is a T2. So that's T2. I'll put it together because it's the what? Is the hypotenuse here, longest side. So T2 we what? 100 divided by what? Sine 60. That will give you 115.5 Newton. So we've gotten our T1 and our T2. Of course, we were told to get T1. T1. That was the question. We were told to get T1, but we got T1, and I just showed you how to use this SOHCAHTOA to solve for T2, because I think this formula, this SOHCAHTOA, I think is faster than the sine rule. That will mean I feel it's faster than the sine rule. Just look at what is available. If you have opposite and hypotenuse, if you have adjacent and hypotenuse, if you have opposite and adjacent, it will determine on the one you use. Maybe it's sin theta, maybe it's cos theta, maybe it's what? It's tan theta. But any one out of the two that works for you, it's fine. They will both give you the what? The same answer. They will both give you the what? The same answer. So let's look at this question. This question says that a body of mass 0.5 kg is suspended by a string pulled by a horizontal force of 12 Newton, as shown in the diagram above. So they are saying that this body is a mass of what? Let me say blue marker for contrast. A mass of what? 0.5 kg, and is suspended by a string pulled by an horizontal force of 12 Newton. So this is the horizontal force of what? Of 12 Newton, as shown in the diagram above. So this force is 12 Newton and it's pulling it horizontally, while the weight of this mass is acting downwards. Please, the weight of a body always what? Acts downwards. As I'm standing like this, I have weight, and my weight is what? Is acting downwards to the floor. So the weight of this body is what? Is acting downwards. That's what? Is mg. Then this is the string. This is the string. This is the string that is suspending this mass. This horizontal force is pulling it like this, while the mass itself is weight is what? Acting downwards. So weight too is also a what? A form of force. So the weight acting downwards is a force. There's an horizontal force pulling it here, and this string too is suspending it. So it's applying a tension to this mass. So we're asked that if the body is in equilibrium, we should calculate the what? The tension in the string. If the body is in equilibrium, we should calculate the tension in the string. So this is another question which requires you to use the principle of what? Of the triangle of what? Of forces. So what we'll first do is to represent this diagram, these forces, is to represent them in a what? In a triangle. And it's very, very simple. Very, very simple. Trust me. Very, very simple. And to solidify our knowledge, we will look for the T. We'll look for the okay, it's T, just T tension. That's one tension we have there. If we add to tension, we have done it in two ways. But let us do it in a straightforward way. So let's see this diagram. Now, this one is acting downwards, right? So this is it. Why the 12 Newton is acting this way? while this one is going this way. So it's one going what? It's one going like this. Mind my diagram. So this is what? This is a triangle. So this is what? This is 12 Newton. This is the mass. This one like this pi is this one 0.5 kg. So remember, they gave us G as what? 10 meter per second. So to look for the force here is what? Is MA. So that be what? 0.5 times what? Times acceleration due to what? Gravity, which is what? 10. That be what? 5 Newton. So here is what? 5 Newton. So when I asked to look for what? To look for the tension in the string. So this is what? This is tension. So this is quite simple. This is quite simple. They are at right angles to each other and are looking for the tension. So we can use what? Pythagoras theorem to look for this. So that is what? C square equal to what? A square plus B square. Remember, this works in a what? In a right angle triangle. And after drawing this diagram, it is a what? It is a right angle triangle. So that will be what? T square equal to what? 5 square plus 12 square. So T equal to what? 25 plus 144. And that is T square equal to what? 169. Then you take square root of both sides. Then T is equal to what? 13 Newton. It's that simple. They did not give you any weird angles, so don't stress yourself. So this is just what? The literal answer. This is the literal answer. I still want us to take one last example. Let me see if we can get that from my phone. Yeah, let's take this example. It's very, very quite simple, but you will see it a lot in your JAMB and your post UTME. So I feel that I can clean this place. Clean this place. So this is the example we are treating. It's just a diagram like this. And we have two ropes. Now, the ropes are attached to this retort stand or to this wall, anything you call it. So that is what? This is a diagram. So they are holding a box. They are holding a box. They are holding a box. And the box is weighing 20 what? 20 Newton. Is weighing what? 20 Newton. And the angle they form here is what? 30 degree each. 30 degree each. Then we're asked to look for the tension in the rope TT. So the tension in these ropes, they are equal. So that's why they are the same T and the same T. So these two ropes are holding this body 20 Newton. So this body is weighing 20 Newton and the weight, of course, is acting downward. While the pulling force is the tension, they are acting what? They are acting upwards. So remember, they make this angle to the what? To the horizontal, not the vertical now. This angle is what? Is the horizontal. So if we want to represent this in a triangle, it's quite simple. Just know what? This 20 Newton is acting what? Downwards. So it's what? 20 Newton. Then, since these two tension, they are equal and they make an angle to the what? To the horizontal. What we can do is to call this, to draw this like this, and to draw this one what? Like this. Mind my drawing. I'll shoot this down a little bit. Call it what? Like this, and call this like this. So, but if we are to go this way, you will see that we can't just put 30 degrees here. This will be wrong because this is to the what? To the vertical. Because this is a vertical line, of course. You understand? So we can't do it this way. We can't put 30 degree here. So we want the angle to the what? To the horizontal. The angle to the what? To the horizontal. So what you do is what? Subtract this from 90 or you do something like this. You understand? So if you are to subtract this from 90, you get what 60 here, and you get what 60 here. So what you put here now be what 60, and now be what 60. Do you understand? To be 60 and 60 and what 60, because they make 30 degrees to the what to the horizontal, and this is a vertical line. So this is what a vertical line that I draw here. So they make what 60 degrees to the what to the vertical, but 30 degrees to the what to the horizontal. So it's quite simple. So this is what T, and what is what this T. So we are asked to look for the what the tension in the rope. So what you can use to look for it here is just what using sine rule. You can use what you can use sine rule, because this is actually straightforward. This is looking like an equilateral triangle. So here is 60, yes, it's here also the what be 60. So it's quite simple. So since there are two equal tension, just look for one and you've gotten both of them. So that'll be what T over sine 60. We got to what 20 divided by what divided by sine 60. So I hope that if you're a good student, you know that what this T is what is 20. Of course, since they're equal. Of course, it's an equilateral triangle, so everything will be equal. All sides are equal in an equilateral triangle. So that is T over sine 60 equal to what 20 over sine 60. So you can multiply that with 20 times sine 60 over sine 60. So sine 60 cancels sine 60. You have your T equal to what 20 Newton. As simple as that. So let me recap again. We have two ropes pulling a block that is weighing what 20 Newton, and the weight of the block, which is its force, is acting what acting downwards. But these two ropes are pulling this block, they are pulling it upwards, and they are acting in this direction. So they make 30 degrees, an angle what an angle 30 degrees to what to the horizontal. So we want to like represent it using what the principle of what triangles. So this 20 Newton is what is going down vertically. So this is what the vertical what line. So these two tension, they are equal as we're given the question, because they wrote T and T here, showing they are what they are equal. So they are going what this way, and then put the arrow this way. You understand? They are going this way. Why this one is what is going this way downwards. So how do we now input the angle? This line is a vertical line. This line is a what? Is a vertical line. So, but this angle was made to the horizontal. So we can't put angle 30 here. We instead what put what angle 60. So why do you put angle 60? Because I drew an imaginary line here, which is vertical. So if we have 30 here, what will be here will be what will be 60, because 90 minus 30 will give you what 60. This is like a right angle here. You understand? The same thing here. So they make what angle 60 degrees to the what to the vertical. So when we got the angle here, we now use sine rule to get the what the tension. So that's all I think I can do in this triangle of forces. So what we are going next into is the principle of